Okay, let's finish up this Unit 3, a little bit more discussion on water and on pH. And let's take a look at this little diagram. This shows a representation of a water molecule and helps to understand why water is polar. You'll notice that the oxygen is large and it is at one end, and the hydrogens tend to be connected to the opposite end. This is the positive end, H plus. O minus is the negative end over here. So if these are end to end with opposite charges, that's a hydrogen bond. It's why water is sticky, and it's why water follows water. When you pour it on the ground out of a glass, all of the molecules follow the leader. When you have it in your bloodstream, the molecules follow each other through the capillaries. And it's why that works so well. It's what's called capillary action. It's because of the surface tension of water. And it is why water is sticky enough for certain insects to walk right on the top of them. So that works pretty well. It's also why water is a universal solvent, because this end, this negative end of water molecules can surround positive ions that have dissociated from crystals in the water, and they become suspended. The other end of the water molecules can surround the negative ions in the water, so that one can be suspended. And when we run out of water molecules to dissolve those things that are ionic, guess what? Of course, it sits at the bottom of the glass like too much sugar or too much salt. That's why it won't dissolve. There's not enough water to suspend it all with the opposite poles of the polar molecule. And also, another example of how effective water is at dissolving things is to look at the lime that's dissolved in limestone and the caves that have been formed over the years, and also at the cement underneath the roof of your garage, where you can see the erosion of the cement because it's been dissolved little by little over time by the water that drips off of your roof. Okay, now let's talk about the pH of water and the pH of anything, really. pH is important. pH is the negative log of the hydrogen ion concentration with a scale that runs from 1 to 14. What does that mean? Well, basically, when we look at pH, we look at pHs that are low numbers, that are acidic. pHs that are high numbers are alkaline. Acids are sour. Bases or alkaline materials tend to be slippery. I'm sure you've had bleach on your hand before and maybe didn't understand why it was slippery, but it is slippery. You can be burned by alkali and you can be burned by acid. In fact, the acid in your stomach is strong enough, acid of pH 1 to 2, is strong enough to burn up some of the lining of your stomach, and it's why stomach cells are so mitotically very active, because they have to replace damaged cells all the time, more so than most other tissues in your body suffer damage. We can look at this scale again in a different diagram, and we can see that here we've superimposed acid rain and what happens to our lakes and rivers if there's acid rain, and to the fish populations that cannot exist. pH is extremely important to your blood chemistry and to the homeostasis and the natural functioning, the proper functioning of your body. The hemoglobin is a protein molecule, for example. We've already said that pH really affects protein molecules and their shape. If your blood pH gets off, then you can't breathe very well, and your hemoglobin molecules have a much higher are a much greater problem bringing oxygen in and taking CO2 out because their shape changes. And what can change the pH of your blood to make it harder for you to breathe? Well, altitude doesn't change the pH of your blood, but you know what does? Smoking and also alcohol. So if you're smoking heavily, your blood pH changes and you have a harder time breathing. If you're drinking a lot of alcohol, you have a hard time breathing. If you're at high altitude and not used to the high altitude, it really makes it bad for you. And in fact, it can be so bad that you will get cold and never be able to get warm until you go down the mountain, because there just isn't enough oxygen being carried into your cells for the production of ATP and the processes that release heat to keep your body warm. That's just a fact. Okay, in fact, it happened to me at high altitude in Estes Park one time after I lived in Louisiana and went on a vacation out there, and I got up to Estes Park, got in a motel room, and just about froze. And if I had only known what was going on, I could have gone to the fire station and got a little oxygen. Instead, I didn't discover the problem, and I was confused by it all until I went down the mountain the next morning. So what is pH? pH is the negative log of the hydrogen ion concentration on a scale from 1 to 14. What does that mean? Well, first of all, it is the measure of the concentration of hydrogen ions in a liter of water by mole. So let's take a look at pH 7 or pH 6. pH 6 is 10 times more concentrated than a pH 7. Let's look at why. A pH 7 is 1 times 10 to the minus 7. That's what we mean by a negative log, base 10, of the hydrogen ion concentration. So to write 1 times 10 to the minus 7, we write 0.00000001. That means, I can add it in here, we are 0.000001 mole of hydrogen ions per liter of water. And a mole of hydrogen is 1 gram, and a mole has 6.22 times 10 to the 23rd power of 10. 6.22 times 10 to the 23rd, that's Avogadro's number. 6.22 times 10 to the 23rd molecules per liter of water, or molecules, if solid, is a mole. So if we look at a pH of 7, then we would take this number and multiply by this number, and we would get 6.22 times 10 to the 23 minus 7. And what is that? 16. Oops, 16. So that's how many molecules of hydrogen ions are in a liter of water at a pH of 7. Now, what if we have a pH of 6? 6 is a smaller number, but there's going to be more hydrogen ions. Because if we multiply it by that instead of this, then 6.22 times 10 to the 17th is 10 times more. If we go to a pH of 5, pH of 18, 10 to the 18th is 100 times more. Those are extremely large differences in the number of ions that there are to react with different organic molecules or other ions in the water. So you can see that relatively small changes in these numbers in pH really represent large changes in the potential for chemical reactions to occur, and they do occur, and they do have significant effects on your homeostasis. So if you ever wondered what they meant, you maybe didn't think about it, said, well, pH is a negative log of the hydrogen ion concentration. Did you ever stop to think about what that means? It means 1 times 10 to the negative power, whatever that pH is. And that's how the scale is, from 1 to 14. So we have from 1. So what's a pH of 1? 1 times 10 to the minus 1. Here, pH of 1. 0.10. 1 times 10 to the minus 1. 0.10 moles of hydrogen ions. Whoops. Hydrogen ions. pH of 14 is, just write it out here, 0.2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 moles of hydrogen ions. I always do that, sorry. So you can see that between these two numbers, pH of 1, pH of 14, there is a huge difference. Huge difference. So think about that a little. See if you can remember it. It's pretty important when it comes to the chemistry of your body, its physiology, and your health. So have a nice weekend.